Welcome to another episode of Terry's Notes, and today I'm going to be looking at the May 2016 paper, question 5. So, the diagram below, not drawn to scale, shows two straight lines JK and JL intersecting a pair of parallel lines EF and GH. So our parallel lines are EF and GH. And first thing they want us to find is to find the value of x, right? Given reasons for your answer in each case. Okay, so we know that JL is a straight line, and we have this angle here, which is 128, and we want to find x, right? Now, this here is a straight line, so therefore this entire angle here is 180 degrees. So therefore x is equal to 180 degrees minus 128 degrees, which is equal to 52 degrees. Right, so this is 52 degrees. So that is what x is, right? So x is 52 degrees. Now I need to find y, right? Now, EF, that is this, and GH are parallel lines, right? And we have JL, which is this line here. Now, y is a corresponding angle to 128. So therefore, y is also equal to 128 degrees. Right, and that is because they are corresponding angles. Right, now let me show you what I mean here. If I have two parallel lines here, and I have a line passing this way, this angle here, if this is A and this is, let's say, B, A is equal to B because they are corresponding angles, right? So the similar scenario is taking place here. The 128 degrees is corresponding to Y, right? Now we need to find W. So W is this angle here. Now, what we do have is a triangle. That is this triangle here. So this angle here has to be 52 degrees, right? Because it's corresponding with x. And we need to find this angle here first. So this is a straight line here. So therefore, to get this angle, this will be 180 minus 100, which will be equal to 80. So therefore, this angle here is 80 degrees. So we know this is 80 degrees and this is 52. So therefore W, because we have a triangle, remember the angles in a triangle add up to 180. So W will be equal to 180 degrees minus 52 degrees plus 80 degrees, which is equal to 180 degrees minus 132, which will be equal to 180 minus 132, which is equal to 48 degrees. Right? So that is how we find W. Now let's look at the next part of the question. We have a transformation here. So first part, so we have triangle RST, and it undergoes a transformation, and it ends up at R prime, S prime, and T prime. Describe fully the transformation that maps RST to R prime, S prime, T prime. So we know that it is not an enlargement because the two images are the same. We know that it's not a rotation because the triangles have the same orientation. So it could be a translation. Let's look at this point S here. How does it end up at S prime? We go 1 across 2 across, and then we go 1, 2, 3, 4. Alright, so let's take a note of that for now. So we went 2 across and we went 4 down, which is minus 4. Right? Let's try some of the other points. We have R, so we go 1, 2 across, and then we go 1, 2, 3, 4. So you realize we end up with the same translation, 2 minus 4. Let's do it for T. We go 1, 2, and then we go down 1, 2, 3, 4. Right? So therefore, S goes this way. Then we have R going this way. And then we have T going this way. Alright? So therefore, when we have to describe the transformation, we have to say it's a translation. Right? And the transformation vector, or the translation vector, is 2 minus 4. Right? So it's a translation, and the vector is 2 minus 4. Now, hold on 1 second. Right, so we have triangle. Okay, so the second part says triangle RST is reflected in the line x equal to 6. Sorry. On the graph, draw the triangle R double prime, S double prime, T double prime, right? Which is the image of triangle RST after reflection. So the first thing we need to do is to draw this line, the line x equal to 6, right? Now the line x equal to 6 is really this line here. So this is x is equal to 6. Right? Whenever we have to draw a line x equals something, it's a vertical line. Right? Sometimes students get confused as to which line it is, if it's horizontal or vertical. It's a vertical line. And we are undergoing, this is the triangle that we are reflected in the line x equals 6. So let's start with S. If we reflect S in the line x equal to 6, this becomes S double prime. Right? It must be an equal distance behind the mirror line. So R is 1, 2, 3, 4. So we go 1, 2, 3, 4. So therefore this here should be R double prime. And T is 1, 2, 3, 4 units in front of the mirror line. So there should be 1, 2, 3, 4 units behind the mirror line. So therefore this represents T double prime. So therefore the triangle they want is this triangle that I'm drawing here. Right? So this is the image of RST after it is reflected in a line x equal to 6. Okay?